class. Now we are here to learn about functions. Now we are going to start a new topic about function. So we will going here study about from the James Stewart's calculus. First of all, we will introduce about the function. What is meant by function here? Okay, so first of all, we will discuss about some phenomena, like examples. You know that you have some examples, like first of all, when you are going somewhere and you are doing like this, here is a machine. Here is a machine. This is machine. If I am going to give it an input like X, this machine will operate on this input, and here will be the function. It means I have given an input. This is known as input. Okay, so I have given an input. After that, this machine will work on this input, and after working, it will give us an output. That is known as, it will work like this. There will be a function. It means it operate on this input, and we will be given an output that is known as f of x. This is our output. If there are like sticks, we can say sticks, and I am going to input it in this machine, and this machine is from where? In factory. There is a factory of pencils. If I am going to give a stick in this machine, after operating, there will be an output which will be the pencils. Okay, so it's known as a functions. Now theoretically, what does mean by function? Function is a one-one correspondence or a rule. What does mean by it? That is the one-one correspondence or a rule. So a function is what? It is a rule by which it relates elements of a set A to the elements of set B. It relates elements of set A to the elements of set B. Okay, so it is known as a function. But what is meant by the relation? So relation will be there will be two conditions. So condition 1 will be here. So condition 1. Condition 1 will be every. So these are two sets. Okay. So elements of set A will correspond to the elements of set B, and there will be one-one correspondence. What does it mean? One-one correspondence. That is known as also a rule. The elements of first sets are known as what? Domain. Or we can say that input. Okay, and the elements of set B are known as elements of set B are known as output. Okay, so now we can say, and this is what? This is also known as codomain. Okay, so what does mean by function? Function is also a relation. Function is also a relation, also an input and output. Okay, it is also among the between dependent and independent variable. Okay, what does mean by dependent and independent variable? You can say that if I'm going to be given an input and output is totally depends, or output totally depends on sticks. Okay, if I will be giving 1 meter stick, then there will be as much as pencils as much as I am going to give sticks. Okay, if there is 1 meter stick, if I say that there will be from 1 meter there are 3 pencils, and from 2 meters will be the 6 pencils. So the pencils, the product of pencils depends totally on the length of stick. So we can say that totally the pencils, it means the products or the product we are given, it means the pencils are totally depends upon the sticks we are giving, and the sticks are known as input. Okay, so input is known as, you know that very well, and you have to remember that input doesn't depend upon output, but input is what? Input is independent. So input doesn't depend on output, but output totally depends upon input. So we can say that X is what? Independent, and output is what? That is dependent. Okay, so now here are two main rules to identify that whether this given also is a function or not. Given two relations are functions or not. If there are two definitions. One definition is every domain has its range, and number two is every domain has unique range. Okay, every domain has unique range. Okay, so what does mean by unique? You can say, and how these two definitions works we can see here. If there are given two sets like A and another set is B. Set A has A, B and C, and here 1, 2 and 4. So there you can say that from the definition 1 we can say if A relates to 2 and B is mapped with 4 and C is also mapped with 2. So from this you can say, from first of all we will if we see that is this functions qualifying these two definitions. If yes, then that will be the function. If it doesn't, then that will be not a function. We can say every domain has its range. So you can say every domain has its range. Okay, so first definition is qualified. Number two is every domain has unique range, only one range, single range we can say. So you can say that A has only two range, and B has 4, C has 2. So it's qualified that every domain has only single range. So it is a function. From another example you can say. So let's now another example we are going to take. There are two sets, set A, B, C, and then another set B. 1, 2, 3, and 4. Okay, you can say if A relates to 1 and B relates to 2 and B also relates to 4 and C also with 3. From this, for a function there must be two conditions satisfied. The number one condition is what? Every domain has its range. So you can say that from the first condition is satisfying here, so that we can say every domain has its range, P also has range and C also has a range. But the second definition says that every domain has only single unique range. From this, A has single range and that is unique range. But from B has two ranges, that is 1, 4 and that is 2. So here it is not a unique range, so it will not be a function. That will be the functions. Okay, so these are all the basic concepts about the functions. Here if we go to relate about different examples from the another point of view, you can see that there are a large number of problems in our daily life which are known as a function. So every if you can say that you can identify the different examples of the functions from your daily life. Okay, inshallah next video we will see different types of functions and how to, and another point of view about the functions.